method. We're going to look at question 3 from exercise 18B. Okay, so we want to find the minimum value of this, and we're given some extra information we're going to use later. Okay, so if I were to, just to make things a bit simpler for us, if I make v equals x squared plus y squared, where v stands for value, um, I can't find the minimum value of this because I've got two variables at the moment. Okay, that's why they're giving me this. So if I were to make y the subject here, so I get y equals 2 minus x, I can rewrite v in terms of x only. So instead of y, we have 2 minus x, 2 minus x squared. Okay, now I can now differentiate. Okay, so I differentiate. Remember, to get the maximum value, you always have to differentiate, or minimum value in this case, minimum value. So dv dx in this case equals, I'm going to do that like that. So I'm going to go like this and put this on. So x squared, and you can type brackets in as is. So 2 minus x squared, and I'm going to differentiate. Interactive calculation diff. Okay, I get 4. So that's 4x minus 4. Now we're not done yet. To get the minimum, to find minimum, we let dv dx equals 0. We can solve it. Okay, so you can do it in your calculator. You should get um, x equals to 1, essentially. Okay, so x equals 1 is when the minimum occurs. It's not the actual minimum value. So minimum value would be, so b min would be when you sub 2 back into the original equation, which is this one. Okay, so we've got 1 squared plus 2 minus 1 squared. So the minimum value would be 1. 2 minus 1 is 1. 1 squared is 1. 2. So the minimum value is 2. Okay, so that's how you work that equation, or that this out. So if you were to do it on a calculator, you'll go this equals 0. Then you'll go interactive and solve, and you sub that one back into the original. So you're given x equals 1, and you should get 2. So that's how you do question 3. Now for question 5, we've got a diagram of cross-section shown, and the curve is defined here. So as you can see, the domain is 0 to 20, so you're starting at 0 and you're ending at 20. Okay. Find the height of the bank when x equals 5, 10, 15. That's pretty straightforward. You just type in the equation on your calculator. Okay, so I'm going to go x squared divided by 400 multiplied by 20 minus x. And I want to sub in 5, 10, and 15. So I'm going to do that. X equals 5. X equals 10. Okay, I'm not sure if the book has a standard or decimal, but you get the idea. So x equals 5, x equals 10, and x equals 15. So that's pretty straightforward. So find the height of the bank up there, and your answer should be in meters. I assume they want in decimals, but I'm not sure depending on what the book wants. Okay, so for B, find the value of x for which the height is maximum, state the maximum height. Okay, so remember, to get the maximum, you always have to differentiate. Now, since this is in terms of one variable only, we can find dy dx. Okay, so just differentiate this original equation. Okay, and I get this value. I'm just going to simplify it, and I get that. Okay, now what I need to do now is we want to find the value for which is maximum. So I found dv dy dx. I need to let that equal 0. So I'm just going to let that equal 0. And I'm going to solve it. Interactive and solve for x. Okay, I've got two possible values. Okay, which is the maximum value? Okay, which is the maximum height? Now, let's check. Okay, you check by subbing into the original. So my original is here. But as you can see, I'm already pretty certain 0 is not going to be my maximum. This might be a stationary point, meaning that if this graph were to continue, this might be a minimum, but it's definitely not a maximum. But we'll go to the calculator to show you that, okay? So I'll go given x equals 0, because that's one of the, that's saying the stationary point happens at 0 and 40 on free. At 0, you get 0, so obviously that's not a maximum value, but if I go sub in 40 on free, let's see what we get. Okay, yep, we get a high value to 0. So 80 on 27 is the maximum volume, okay? So you have to answer the question two parts. For what value of x, or for which the height is maximum, and state the maximum. So the x value which results in the maximum volume is 40 on free, and the actual maximum volume is 80 on 27. So you gotta be able to answer the two parts and understand what each part tells you. Now, part C, find the value of x for which dy dx equals 1 on 8 and dy dx equals negative 1 on 8. So really simple. Dy dx represents the derivative. So this is my not my derivative. This is my derivative here. So I'm going to paste this in. You're going to make that equal to 1 divided by 8 and solve it. Interactive, advanced, solve. Okay, and you've got two values. Now I can't really tell what these values are, so in the exact mode, so I'm just going to quickly turn to decimal because I want to check whether it's over my domain. Okay, so you've got two values. They're not over your domain because they're between 0 and 20. Great. So you got two answers, and they're both acceptable. So go back to standard, just type this in, and if you want them to combine it, just press sim. Okay. And then I'm going to solve it for negative 1 over 8. Okay, and I again want to double check whether my answers are within my domain. Okay, and obviously for the C part 2, the negative won't be part of my domain, so I can't accept that answer. I have to accept the second answer only. Okay, so if I want it exact, I'll go back to standard. So you don't want this one, you want that one. Okay, so you don't want the first one, you want the second one. Okay, so hopefully that helps you do question 3 and 5. For 6, I'll do another video on that.